Good morning. Today we will discuss about the concept of that is a on delete cascade and on delete set null. So in which situation it is required and what is the by default behavior. See, whenever you are using the concept of that is on delete cascade, see it is written in red. Why? Because it is a reserved keyword. What is on delete cascade and what is on delete set null? That we want to discuss today. Generally, what happens whenever you are doing a primary key foreign key relation, right? At that time, you must need to remember some point to remember. Let me write here some point to remember for primary key and foreign key. We can declare maximum or minimum, you can say we can declare only one primary key per table. Definitely we can combine the multiple columns. So if you think that, sir, I want to put a primary key on the multiple columns, then we can declare composite primary key. What is composite primary key? We can say that it is a collection of multiple columns. So in short, the combination of the columns should be unique and it must not enter the value that is null. Now, I want to know one more thing, that is what we can declare only one primary key per table, but we can declare multiple foreign key per table. We can declare composite primary key, even we can declare the composite foreign key. One more thing is, primary key is always unique, while foreign key may contain the duplicate values. Now what problem is, for example, let me give you the live example so you people can get the better idea. For example, I have a table and the name of the table is, for example, college. Now, here in college table, the by default behavior is what? For example, if this is a college code is, for example, number of 3 digits, and I'm writing here the primary key. So I'm writing here primary key, college code, now name of the college. Here in name of college, I'm writing that the name of college is, for example, it must not be null. And this is the college, right? We can insert the record into college. So let me insert few records into college. So we can write here insert into college add values. Suppose I'm entering the value that is 501. The name of the college is, for example, Athmia University. Right? You can press a slash to insert the record. You can copy paste the same. Now I want to add one more college over here, that is 502, and I'm writing here that is M and Virani Science College. There are two colleges in my table. Now I'm creating one more table, that is a student. Now what problem occurs? See carefully. We know that each and every student should have the enrollment number and it must be a unique. So I'm writing here enrollment number of 10 digit and it should be a primary. Once it is done, here you can give the name of the student. For example, name of the student is 30 character long and definitely each and every student must have the name. Then you can define some details about the student like mobile, city, email ID and all these things. But right now I'm interested in giving the primary key foreign key relation. It means student is studying in the college, that is college code. So I'm giving here the number of 3 digit. Now I'm giving the reference that a reference is on college. It means the college code column of college refers by the student. It means this entry in the college table required first, and then we can make the entry into student table. So here I am trying to insert the record into student, and that is what, that is values. For example, student number is, for example, enrollment number 1. The name of the student is, for example, Arjun, and studying in college 501. Now let me insert one more record over here. Definitely more than one student can study into one college. That is allowed. So here you can write here Kuldeep. So Kuldeep is in 501. Now you can just simply copy the statements and you can paste into your SQL. Then you will be able to see that, see what happened. The value too large for the column, and that is yes. I defined the varchar to 30, right? And I entered the value that is a large. So that is the reason why I'm not able to insert the record. So let me change something. Instead of this long, let me insert only 502 MN and Virani. Once it is done, now you people will be able to see that the record is created. Now let me check the record first. So I'm writing here select star from college and I'm writing here select star from student. Now look carefully what I'm doing. See, this entry in the student table never be possible without the college entry. It means, suppose if you think that, sir, I want to insert the record, into student table. Let me copy this. And I want to make here college code number 3, that is 503. We all knows that the entries is not allowed if the college is not exist. Suppose if you press slash, then it will give you integrity constraint violated. It means if the parent record is not available, then you cannot insert the record into child. Now what happened? See, maybe a chance people do what? They make the fake entry. How? Suppose try people who want to cheat, then they can do what? They can enter the fake entry over here of college. For example, the name of the college is Gurukul. Now I'm making the entry of 503 first. It is inserted. Now I'm trying to insert the record of Keyur. It is also inserted. Now what happened? If you check carefully, then you will get the record in college, you will get the record in student. Now what people will try? People will do what? Will try to delete the record from this college. Suppose if you write the delete statement from college, that is delete from college, where that is college code is equal to 503. Now what happens? See, we cannot delete the college if the students are exist. We first need to remove the students, then and then we can remove the college. See, here you will get an error, and the error is what? Integrity constraint violated. It means the thumb rule is what? Here, let me write the thumb rule. We cannot remove the records from parent table if child is exist. For example, in our case, the parent table is college and the child is a student. So I cannot delete the college if the students are exits. If you see carefully this particular statement, then it makes a sense. It makes a sense. What sense? It means that this record I need to delete first. Then and then I can delete the record of this 503 Gurukul. So what? Suppose if I want to delete this particular record, I'm not able to delete this record. What I need to do? First, I need to delete the record from student. So what I need to write? Delete from student, where that is enrollment number is equal to 3. So that record will be deleted. So KU record will be deleted first. After the child is deleted, you can delete the college, right? And now you can check that there is no record available in college. There is no record available in child. Now the requirement is what? My requirement is very simple. Whenever I am trying to delete the record from parent, it means if I am trying to delete the record from parent, then my child record also should be deleted, right? So by default behavior is what? By default behavior is we cannot remove the record from the parent table if the child is exist. But But what if I want to do this? But what if I want to do this? If you want to do forcefully, then if you want to do forcefully, then you can use the concept of on delete cascade. So what on delete cascade will do? Let me write here. Whenever we delete the records from parent table, it will automatically delete the records from child table, right? That is the concept of on delete cascade. So how we can do this? Let me show you over here. So let me drop the table. Remember students, even you cannot drop the table college first. If students are exist, then we cannot drop the college table first. First we need to drop the table of student. If all the records of the students are deleted, it means the table is deleted of the student. Then and then you can drop the table college. So this is the sequence. In short, the thumb rule is what? In short, the rule is we we cannot drop the primary key table first. It means not primary key, but let me write here, we cannot drop the parent table first. First we need to drop the table of child, then we can drop the table of parent. So first we need to drop the table of child, then we can drop the table of parent. Let me give you an example over here. For example, see, the table college and students are dropped now, right? Now I want to recreate the table and I want to use that. Suppose if I am removing any college, for example, if I am removing the 501, then all the records belongs to that particular college must be removed from the child also automatically. How we can do this? So very simple. Whenever you are writing a reference key, references, here you can mention on delete cascade. So this is the keyword that you can use with the reference table. What is the meaning of this? The meaning is it will be automatically deleted if the parent records are deleted. So this is the thing. Sometimes it is required. Why? Because suppose might be a chance I have a parent table which has the 25 other foreign table references, right? Now whenever I remove the parent record, I want that the other 25 records also should be deleted. At the same time, you can use the on delete cascade. Let me copy this. So now you people will get the idea. See what happens. See, the first table is created, that is college. Insert the record. 3 records are inserted. Then another table is created, that is a student, in which the reference college is also there, but on delete cascade close is available over here. Now there are 2 records are inserted. Let me check the record available in the college. Let me check the record available in the student. Now suppose if anybody trying to delete the record from college, then the record from the students will automatically delete it. It means, see here, there are 2 records belongs to 501. Suppose if I am trying to delete here, delete from college, where college code where college code is equal to 501. See, only one record deleted from the college, but if you look carefully, see, in college the 501 is deleted, and if you see here select star from students, there are no records available over here. It is, what is the meaning of this? The meaning that whenever you delete the record from parent table, the record will be automatically deleted from the child table if you are using the concept of on delete cascade. Now what happened to this particular thing, that whenever you are using the on delete cascade, it means if the record from the primary key, that is from the parent table, is deleted, then the record from the child will be automatically deleted, and here you can see that the no records of the students are there. But sometimes we want the output in a different way. We want that whenever we delete the record from the parent table, right? So condition is the same. Whenever we delete the record from the parent table, I don't want to delete the record, but I want to set the null in that particular respective column, and later on I want to give the another college code to that particular thing, another department to that particular thing. It means you want to set the null. So what on delete set null will do? Whenever we delete the record from parent table, it will set the null in respective child. So what is the concept? This very simple. Instead of on delete cascade, I want to make it here on delete set null. Definitely, I want to drop the table college first. So we cannot drop the college table first. So what we need to do? We need to drop the table student first. Then we can drop the college first. Then after you can delete the college. And now you can copy the same thing and you can paste over here. Now you people will be able to see that the table is created with the different approach, and the approach is on delete set null. So now you can select the data from college. So whenever you select the data from college, there are three colleges are there. Select star from student, there are two students are there. Now suppose if I am deleting the record from college, where college code is equal to 501. Now what happens? See, whenever I delete the record from college, now the record from student will not be deleted, but the college code value will be set to null. See here, the college code value is set to null. And now what is the biggest advantage? I can assign the different college code to them. It means later on we can upgrade them. So we can write here update the student set college code is equal to 502. It means the college code earlier was 501. I deleted the record from the college, and that is the reason why student having the college code is null. So I'm writing here condition all the students whose college code is null update with the 502. So two records will be updated, and as a result you will be able to see that later on I change their college code. It means I transfer the student of 501 college to 502, and I just deleted the record of parent, and the child is already there. Child having the college code that is changed. It means the students are transferred to the different college code, and that you can achieve using the concept, and that is known as a on delete set null. So there are basically three different options. One option is whenever you try to delete the record from parent, it will never allow to delete the record from the parent if the child is exist. This is the first approach, and this is the default approach. Now suppose if you think that sir I want to make the changes into this, then in references you can define on delete set null, or you can define on delete cascade. if you write here on delete cascade, then whenever we delete the record from parent, the child record will be automatically deleted, right? It is like a permanent removal of the department from any organization. But I want to allocate the students to the different college. I want to transfer the student to the different college. So what we can do, whenever we delete the record from parent, that is, for example, if I delete the record of college, then I'm just setting the value to null. Once you assign the null, later on you can assign the different college code to them, and that is the concept of on delete set null. Now suppose if you think that, sir, I want the another example of on delete cascade and on delete set null. Suppose if you want the another example, then let me create the table. For example, the name of the table is parent. I'm writing here parent ID, integer, and primary key. Now I'm just writing here that is parent name, for example, varchar 2 30. The table, in this particular table, I want to insert the record, insert into parent values. Now I'm inserting the record into this particular table, that is the parent is load Shiva, right? Now I want to insert the one more record over here, and that is, for example, load Rama. Now I want to create another table, that is child. Here child also have the ID. So each and every child is unique. So I just creating the primary key in child. Each and every child is unique. Child name is also there. So I'm creating here child name. Now each and every child belong to parent. So I'm writing here parent ID, and that is integer. Now I'm writing references. Now suppose if I am writing here references to parent, then what happened? The record will be referred to the parent record. So whenever you try to insert into child, the record must belong to PID of child must belong to PID of parent. So whenever you try to insert into child, and suppose if you are inserting the values, for example, child 101, the name of the child is, for example, Ganesha, belongs to parent 1. Let me insert one more record over here, and the name of the person, name of the child is 102 Karthik, belongs to parent 1, right? Not 2, so parent 1. Now 103 Love and Kush are two child of Rama. So I'm writing here love and Kush both are belong to parent number 2. Now I'm trying to insert this particular creating table and inserting the record. Now see here, if you check carefully, then select star from parent will give you the information about the parent, and child will give you the information about the child. Now there are three approaches to delete the record from the parent. The by default approach is what? Whenever you try to delete from the parent where PID is equal to 1, for example, so I cannot delete the record from the parent if the child is exist. Integrity constraint violated. This is the default behavior. So you can say this is the default behavior that we cannot delete from the parent if the child is exist. Now I want to do what? Whenever I delete the record of parent, then I want to delete the respective child. So what we can do in this particular case, simple, before creation. Now we all knows I need to drop the table child first, then and then we can drop the table that is parent. Now I want to create the table child with the concept that is on delete cascade. It means what? Whenever I delete the record, whenever I delete the record of parent, the child record should be deleted. Now you can check again, select star from parent, select star from child. Now I'm trying to delete the record from parent where PID is equal to 1. Now see, it shows me the one record deleted from parent, but if you look carefully, then there is only one parent is available and there will be only two child will be there, and the child will be, that is from the parent Rama. So the child of Shiva and Lord Shiva, both the records are deleted. Suppose if you delete the record from parent with the ID 2, then there will be no child and there will be no parent. So this is the default behavior of on delete cascade. But suppose if you think that, sir, I don't want to delete the record of child if the record of parent are deleted, then what to do in this particular case? Then you can set the null, and later on you can assign the different parent. So you can set the null. So now what happened? Suppose if you are creating like this, then your records like this, for example, parent have 2 records, for example, child have 4 records. Now I am deleting the record from parent where PID equal to 1. Now what happens? See, your parent record will be deleted, but your child record will not be deleted. So whenever you write select star from child, then your child record will not be deleted. It means the ID is set to null. Later on, you can assign the different parent to this child. Now, what is the biggest advantage? Suppose if I am inserting into parent and I am inserting the ID 3 and I am setting the value here, that is a Parvati, for example, right? So the record into parent values, so record is inserted. Now here you can check that there are 2 parents and here you can check that there are 4 child, but child have no parent ID. It is null, it's set to null because the parent earlier was removed. Now I want to assign that the Parvati is the parent of Ganesha and Kartik. So how we can do this? Very simple. You can write here, update the child, set PID equal to 3. It means the parent will be now 3, that is Parvati, where PID is null. So the child whose parent is null, update the parent ID with 3 and the 2 records will be updated, and now you will be able to see that the parent of Ganesha and Kartika is switched to parent ID 3. It means whenever you delete the record from parent, then by default it not allows to delete the record if the child is exist. This is the one case. The second case is whenever you delete the record from parent, then the child record will be automatically deleted. The third case is whenever we delete the record from parent, then the child record will be set to the null. Now, depends upon the situation, depends upon the requirement, you can choose the best option that is required to you. So this is what about the on delete cascade and on delete set null. Now I want to show you that we cannot use the SYSDATE, that is the inbuilt, we can say that the functions to retrieve the current date and time, that SYSDATE we cannot use in the create table definition. For example, if you think that, sir, I want to create the table that is a test, for example 111, right? I have the ID integer primary key. Now I have the value that is for example date of birth, and that is date. Now I want to check that this date of birth should not be today's date. It means it should be less than the today's date. In short, I want to check that the less than or equal to today's date. It means the date of birth should not be tomorrow's date. So I can never judge that the date of birth is tomorrow's date. So I want to write simple constraint that the check date of birth less than or equal to system date. It means the date of birth must not be tomorrow's date. It must be either today or earlier. How we can write this? See, whenever you write like this, then it will give you an error that the date or system variable wrongly specified in the check constraint. There is no syntactically any error. There is no syntactically error, but the concept is we cannot use the SYSDATE in create table. Now the people will ask you, I want to use this. Not only in create table, see, let me correct this. We cannot use a SYSDATE in check constraint of create table. Right. Now I want to use this. How we can do this? Very simple. Suppose if you want to use this, then you can take the temporary column, that is temporary date. Right. So I'm taking here temporary date column. I'm just giving the date is my data type. Now at the table level, you can check that date of birth should be less than or equal temporary date. And what we can do over here, in default, we can set the SYSDATE. So what is the biggest advantage? The table will be created, right? This is not allowed. It means I cannot use the SYSDATE. So what I tried? I just created this temporary column in which I just entered the default SYSDATE, and now I just check that the date of birth should be less than or equal to temp date. And whenever you try to insert the record, at that time, just check like this, insert into test 1111. Now insert into only the regular column. So don't insert the record into temporary column. So whenever you skip that particular column, your SYSDATE will be inserted. Now you can check. Suppose if I am entering the date of birth is 22nd December 2020, then my check constraint will be violated. If you write like this, then my check constraint will be violated, right? I'm not able to insert the record that is after the today's date. But if I am writing here that is a 20 December, then it will allow me to insert the record. So in short, whenever you want to use the SYSDATE in a check constraint, directly you cannot write a check over here. So we can create the one column in which we can set the default value, and then we can compare that particular column with that particular constraint. Sometimes it requires, and that is the reason why I just showing the functionality how to use the SYSDATE in a check constraint, right? So you can create the temporary column, you can assign the default SYSDATE, and then you can use in a check constraint. So this is the way you can do this. That's it from my side.